Okay, so finally we're to our last inheritance pattern, autosomal dominant. So developing conclusions here. So the pedigree below is for genetic disease or abnormality. We don't know if it's dominant or recessive. We will determine it if it is possible that the trait is autosomal dominant. If it is, we are going to use the following designations. So a big A if you have the trait, a little a if you're normal and do not have the trait, the genetic disease or abnormality. Now, if the trait were recessive, remember we would have done it the flip way. So these ones we're doing autosomal dominant traits. Okay, so assume that it is dominant. So in this case, an autosomal, so that means we don't use the sex chromosomes, right? So in this case, autosomal dominant could either be, right? Autosomal dominant could be, an affected individual could either be that or that, right? So the pedigree shows three individuals, that three of the individuals have the recessive normal phenotype, which would be these, right? So if you only know the genes, write the genotype for these individuals, and keep in mind that the pedigree may not be possible for a dominant trait. So is this one possible for an autosomal dominant trait? No burrs, because all that mom and dad have to give is little a's. So there cannot be an affected child if their parents are not affected. Okay, so that's a big hint as well for autosomal dominant. If a child has it, then one of their parents have to have it as well. Okay, so let's do this one. So this child is affected, so they could be either this or this, right? And then same with this one. This one could be this or this. Now these ones are not. So is this possible? Well, yeah. So dad would give the big A, right, in this case, where mom has to give a little a. So in this case, this daughter has to be this genotype. Whereas in this case, since the son doesn't have it, that means dad has to be heterozygous for it. So since the son doesn't have it, dad would have given this and mom would have given a little a as well. So this one is possible. So what can you conclude about the parents of a child that has a dominant trait? So if the child has a dominant trait, like I said, one of their parents, at least one of their parents, have to be affected. Okay, so same deal. So in this case, we could do AA or AA, right? So they could either be heterozygous for it or homozygous dominant. Now, could they have two children that don't have it? Well, yeah. If they were those, they could have given the little a to their son and daughter there, or daughter and son, however you want to say it there. So this one is possible. So can two individuals that have an autosomal dominant trait have unaffected children? Yes, if they are heterozygous for the trait, right? Their children could receive both of their recessive alleles. Okay, so again, affective individuals are either this or this. Now, they have 3 kids. So this kid does not have it, so they would be this. These kids do. So in that case, both of the parents would have had to be heterozygous if they had a child that does not have it. And then these kids could be either, potentially. Okay. Now up here, same deal, right? But the wife does not have it. Now they have a kid that has it and a kid does not. So that means dad had to be this, because then this daughter would have gotten a little a from both of the parents. Whereas in this case, dad would have given his son the big A and mom would have given the little a. Now, both of these, obviously, if it is recessive here, remember, and both parents don't have it, none of the kids can have it. Okay, but that is how you would map out the traits, and remember, just label the generation numbers so that if asked a question about it, you could say like generation 2, individual 5, and so on. Okay, so in summary, you should now be able to thoroughly explain what a pedigree is. You should be able to analyze pedigrees and tell if they are autosomal or sex-linked, and if they are autosomal, if it is dominant or recessive pattern of inheritance. Same with sex-linked, dominant or recessive. And then you should be able to compare and contrast the different inheritance patterns and what that means with regards to the possibilities of inheritance, and that being displayed in a pedigree. All right, guys, you're going to answer a couple of questions and then we'll wrap up.